Okay, so like AI, right? It
Hmm.
feels like everywhere you look, there's a new headline
Oh, yeah.
about some model getting bigger and bigger and bigger.
Right.
More parameters, more data, more compute, just more, more, more.
More is better.
Right. That's always been the thinking. But
Well,
what if I told you that maybe, just maybe, bigger isn't always better?
hmm. Interesting.
Yeah, that's what we're diving into today.
I like it.
So there's this super interesting article we found, and
Okay.
it's basically laying out this totally new way to think about these big AI models,
Yeah.
these large language models. LLMs is the cool kids call them.
LLMs love it.
And it's all about efficiency. They
Okay.
call it density.
I've heard of this. Density. Yeah. It's starting to make some waves.
Yeah, it's pretty cool. It's not just about how big your model is.
Yeah.
It's about how effectively it uses what it's got.
Exactly. Yeah.
Like, are we getting the most bang for our buck?
Right. Squeezing all the juice out of it.
So how do they even measure this density thing?
Yeah. It's way simpler than you might think.
Okay.
You just take how well a model does on a specific task, right?
So like its performance.
Like its performance, like how well it does on a test. And you just
Okay.
divide that by how many parameters it has.
Ah, okay.
So it's performance divided by parameters.
That makes sense. So it's kind of like, I don't know, comparing like a giant gas-guzzling monster truck to like,
Oh, I like where this is going.
yeah, one
Yeah.
of those little zippy electric cars.
Yeah.
Like, they can both get you where you need to go,
Right.
but one is way more efficient.
Way more efficient, uses way less fuel.
Exactly.
That's a great analogy.
Yeah.
Yeah, so this density thing, it's like, you're getting a lot of miles per gallon with your AI.
Right. You're getting a lot of output for what you're putting into it.
Exactly, for the resources you're putting in. And that's important because, like, these massive models we have now,
Yeah.
they are so big, they need so much compute power, so much energy to run.
That's right.
It's expensive, and honestly, it's not sustainable.
Yeah. Not great for the environment either.
Not at all. So if we can get the same or even better performance with smaller models
Right.
that are more efficient, that would be
Game
it
changer.
would be huge, right? It would make AI more accessible, more affordable,
Yeah.
open up all kinds of new possibilities.
Hopefully, especially for like things where you don't have a ton of resources.
Exactly. Like imagine running powerful AI on your phone
Whoa,
or on a little tiny sensor out in a field somewhere.
that would be wild.
That's the future, man.
Okay, so we got
okay.
density. We're measuring performance over parameters.
Yes.
But how do you actually compare different models using this density thing?
Right, that's a great question because obviously you need some kind of benchmark.
Right.
So there's this idea of relative density.
Okay.
So basically you pick a model, right, a baseline,
Okay.
and then you compare other models against that baseline. And that gives you the standardized way to see how they stack up in terms of efficiency.
I see. So you're ranking them. You're saying this model's more efficient than that one.
You're creating a league table of AI efficiency. You got it.
Cool. So is that what they did in this article?
That's exactly what they did. And here's the really interesting part.
Hi.
They found that sometimes smaller models are actually more dense.
Wait, what?
Yeah.
You're telling me that a tiny model can be better than one of these giant ones?
Yeah, sometimes. I know, it sounds crazy, right?
It does. How is that even possible?
It all might come down to focus. Think of it like studying for a test.
Yeah.
If you try and memorize like every single word in the textbook,
Yeah.
you might ace that particular test.
I could probably do really well, yeah.
Yeah, but if you need to apply that knowledge to something else, you're going to struggle.
Right.
That's what happens with some of these big models. They get so big, they're just memorizing the data, they're overfitting.
Ah, so like they don't actually understand it, they just know the answers?
They just know the answers for that specific thing.
Got it.
But the smaller models, they might be less prone to overfitting.
Okay.
They've learned the core concepts, they can adapt.
I see. They can generalize.
Exactly.
So what does it all mean?
It means we need to think smarter, not just bigger when it comes to AI.
That's a good tagline.
I'll take the credit for that one. But yeah, density gives us a whole new way of looking at these LLMs.
It's a whole new way of thinking about AI in general.
Exactly. And the really exciting question is, if we start prioritizing efficiency,
Yeah.
will we see a shift away from this race to just build the biggest model possible?
Right. Like maybe these huge models are great for research and for like pushing the boundaries of what's possible.
Sure, they have their place.
But if we want AI to be practical, to be useful in everyday situations, maybe density is the key.
I think you're right. And I think it could lead to this whole explosion of new AI tools
Okay.
that are, tailored to specific jobs and tasks.
Instead of just trying to do everything with one giant model.
Right, we could have a whole ecosystem of these little specialized AIs.
That's a cool thought.
It's a really exciting time to be thinking about this stuff.
Totally. This whole density thing has really blown my mind.
Glad to hear it.
Definitely give me a lot to think about.
That's what we like to hear. Thanks for having me.
Thanks for diving into this with me.
Yeah.
And for everyone listening, think about this density thing and let us know what you think, because it feels like we're at this really important moment
Oh, yeah.
in how we're developing AI. So until next time, keep on learning
Keep on learning.
and keep on exploring.
Absolutely.